Today we are going to discuss a chapter that is testing the significance difference for small sample. So this the test which is required for testing the difference between a small sample is known as t-test. So let us start with introduction. So this t-test, it was first discovered by W.S. Gossett. Gossett was a scientist, and he first discovered and published the results of t-test under the pseudonym of student. That is why it is called as student's t-test. Why he published it under the pseudonym of student? Because in a company in which he was working, it was a brewery company, and there he used to see very small small samples, and to test those small samples he discovered a new methodology, and then because of the company obligation, because company was forbidding to publish it under the scientist name, that is why he published these results under the pseudonym of student. That is why it is called as student's t-test. So coming to the test, if the number of observation is small, the distribution remain no longer normal. So when you are having very small sample size, then the distribution will be, it will not be normal distribution, because the condition for normal distribution is that the sample size should be large. So when you are not having large sample size, it will not follow normal distribution, and that is why this normal distribution will change to another distribution, and that another distribution is called as t distribution or student's t distribution. It differs from normal distribution. How this t distribution differing from normal distribution? It differs very minutely, and that too it differs from a normal distribution by its degree of freedom. Degree of freedom. So degree of freedom, about which we have already discussed when we were discussing about the variance. So this distribution, normal distribution and t distribution or student's t distribution, is differing on the basis of degree of freedom. At higher degree of freedom, if you are taking higher degree of freedom, that means if your sample size is large, then t distribution will change to normal distribution. So at higher degree of freedom, the t distribution will resemble the normal distribution. Now coming to the t-test. So when we are applying t-test, so first condition you have already seen that sample size, when sample size is small. So when we have no knowledge of population parameter, when we don't have knowledge of population parameter, that is standard deviation of the population, and use its estimates from the small sample. So what we are doing? We are taking estimating population parameter, standard deviation, and use its estimate from the small sample. So we don't have knowledge of population parameter, and we are estimating those parameters from the small sample. Yes, the distribution of Z remains no longer normal. This Z distribution, that is normal distribution, will not remain normal, and it will be converted into t distribution. So simply it states that when you are having a small sample size, you don't have a knowledge of population parameter, then your distribution will become t distribution. It will not be a normal distribution. You just see in this picture the height of t distribution is getting reduced as the degree of freedom is getting reduced. Here you can see the degree of freedom. As the degree of freedom is reducing, your t distribution is getting flatter and flatter. Now what are the properties of t distribution? Like a normal curve, t distribution curve is also bilateral symmetrical. So there is similarity between normal distribution and t distribution. So it both of the distribution are bilaterally symmetrical. Then also it extends from negative infinity to positive infinity. So if you remember the graph of normal distribution, it is extending from negative infinity to positive infinity. Similarly, this t distribution is also extending from negative infinity to positive infinity. But this curve, t distribution curve, is flatter than the normal distribution curve on account of lower degree of freedom. That is, the area near the tail is larger for t distribution than normal distribution. So this curve is getting flatter. So that means peak will get flatter, but the area near the tails will get increased in case of t distribution. Now, as the sample size n become large, so we have already discussed, when the sample size n become large, it will be the t distribution will be approaching the normal distribution. So these are the properties of t distribution that you may be asked in your board examination or even in internal examinations. Another properties are, less area is found between one standard deviation above and below the mean. So if you remember when I discussed about normal distribution, I told you that between plus minus one standard deviation, suppose this much area is there in case of normal distribution, the same area will be lesser in case of t distribution, because the curve is getting flatter. Another property is t distribution differ in shape for differing degree of freedom. So another important point is that when degree of freedom is getting changed, the curve that you are drawing, shape of the curve will also get changed. So that means the shape of t distribution curve is depending on the degree of freedom. Now, as the number of degree of freedom increases, t distribution approaches the shape of normal distribution. This also we have already discussed. Then another property, both t statistics and its sampling distribution are independent of the population standard deviation. That means when we don't have any idea of population standard deviation, we have already discussed when I was telling about the condition of t distribution, a condition for application of t test, that if you don't have population parameter, and the population parameter is standard deviation, if you don't have population standard deviation, then also you can apply t statistics. The difference between the table value of t and z means the normal distribution table. So it is the difference between table value of t and z decreases as sample size increases. That means as you are increasing sample size, the t distribution will become normal distribution. So this is very important. You have to remember the degree of freedom is the main important feature of t distribution. If you are increasing degree of freedom, it will be approaching towards the normal distribution. Actually, this t distribution is a deviation of normal distribution on account of degree of freedom. Then now we will come to the test statistics. So there are various conditions where we are applying t-test. So first condition is comparison of sample mean and population mean. If you want to compare the sample mean and population mean, so same as of Z test. If you remember the Z test, there also we used to compare the sample mean and population mean. But here the thing is that you are having a small sample size. You are having small sample. So purpose of the test is to know whether the mean obtained from sample size less than 30. So sample size is less than 30. It's same as the population mean. So first of all, we will go for hypothesis writing. So null hypothesis. What will be the null hypothesis? It will be x bar, that is mean, sample mean, is equal to mu, that is sample mean is equal to population mean. So null hypothesis is hypothesis of no difference. So there is no difference between the sample mean and population mean. And the alternate hypothesis, it is actually H1. It is not H0, it is H1. H1 alternate hypothesis is x bar is not equal to mu. That means sample mean and population means are different. So that if you remember the Z statistics, it is the same thing. Here you can apply in t statistics also. The formula is t is equal to difference of both the means. That means difference of sample mean and population mean, and it is getting divided by the standard error. Standard error, that means standard deviation divided by under root n. Now after getting the value of t, we are comparing the t calculated t value with the tabulated t value. Calculated t value with the tabulated t value. For that, you have to see the t table, t distribution table. So I will be showing in the next slide how this t distribution table looks like and how we will see the value of t at a particular degree of freedom. So we will compare the value of calculated value of t with tabulated value of t at desired level of significance, that is 5% and either 5% or 1%, depending on the what level of significance you have fixed for your problem or for your situation. What level of significance you have fixed? We already know what is the level of significance at n minus 1 degree of freedom. So at desired level of significance, you have to see at particular degree of freedom at n minus 1 degree of freedom how much sample you are having, and it should be subtracted by 1, and at that degree of freedom you have to see the table. And based on this tabulated value, suppose if you are having calculated value is higher than tabulated value, if your calculated value is higher than tabulated value, then we will reject the null hypothesis. That means there is significance difference between the population mean and sample mean. So this is how we are testing the t test. Here we are seeing the t distribution table at n minus 1 degree of freedom. Now just see one example, then it will be very much clear to you. Suppose you are having a random sample of 10 gir cow. 10 gir cow and 10 gir cow, the production, daily milk yield. Daily milk yield of 10 gir cow. So this is the daily milk production of 10 gir cows. Now you have to test whether this sample belong to population with average daily milk yield of 5 kg. So suppose that means the population mean is given 5 kg. Now you have to test whether the sample that you have drawn from that population of 10 gir cow out of 100, suppose population was of 100 cow and mean of the population was 5 kg, and now you have drawn a sample of 10 cow, which is the performance of this 10 cow is given here. Now you have to test whether population mean and sample mean are different or same. So here you can see H0, that is null hypothesis is hypothesis of no difference. That means sample mean and population mean are equal. Again H1, here it is H1 not H0. H1 alternate hypothesis is x bar is not equal to mu. That means population mean and sample mean are different. Now here from this sample you have to calculate these things, because you know the formula of t statistics is difference between the sample mean and population mean divided by standard error. So first of all you have to get the sample mean. So for sample mean, for that you calculate summation x and then x bar sample mean is 6.31 and you are having mu already you know 5. Now then because you have to calculate standard error also, so for that you calculate summation x square. That means whenever you are in practical, you will learn whenever you are solving this type of problem, you have to create table. This is the x, then in next table you have to create x square, and at the end of this table here you will get summation x, and here you will get summation x square. So whenever you are solving such kind of problem, you are testing t test, z test or whatever test, it is better to draw a table of different column and rows, and then it will be very easy for you to calculate the different parameters that you need to put into the formula or test statistics. So you got x square, summation x square, then with this you will calculate the value of variance. So variance is 1.217, and with this variance you will calculate the standard error. So this variance calculation already we have learned, and if you are getting variance, you can get the standard error. Standard error calculation also we have already studied when we were studying about measures of dispersion. Now you come to the t statistics. So t is equal to summation x bar minus mu, and this is under such kind of bracket. This means irrespective of sign, you don't have to bother about the sign. If it is coming negative, then you have to forgo the negative sign. If it is positive, then no issue. So x bar minus mu divided by standard error. Standard error means standard error divided by number of observation, and here you have already calculated the value of x bar, that is mean of the sample 6.31, and it is deviated with the population mean already you have got 5, and it should be divided by 0.38. What is 0.38? It is standard error. So in this way you calculated the value of t as 3.45. Now what you have to do? You got the value of t. You have to test the value of t with the calculated value of t with the tabulated value. So for that you have to see the table. So in next slide we will see the table. Here you can see we are having this table. So this is the t table, and value of t is given at degree of freedom. This side you will see the degree of freedom. If you will Google t table, then you will get such kind of table, and in any standard textbook you will get the t distribution table. So on left hand side you will get the degree of freedom in increasing order. So this is the increasing order, 1 2 3 4. You can see 1 2 3 4 like that, and on the upper side you will see the second row is for one tail test and third row is for two tail test, and these are the level of significance. So level of significance for one tail test and level of significance for two tail test. So here I am concentrating about the two tail test. So here at two tail test, for two tail test at 5%. So this is, you can see this is 5%, 0.05%. If you, sorry, this is the 0.5, that is 5%. So at 5% level of significance, what you are seeing at n minus 1 degree of freedom. So how many cows sample size was? 10. So 10 minus 1, that is at 9 degree of freedom. So here is the 9. So at 5% 9 degree of freedom, the value is coming is 2.62. So this is this value we will compare with the calculated value. So calculated value was 3.45 and tabulated value is 2.62. So the calculated value is greater than the tabulated value at 9 degree of freedom. So that means we will reject null hypothesis, and we will interpret that there is significant difference between milk yield of cow in the given sample and the population mean, and therefore now we will conclude that the given sample of cow does not belong to the population with mean of 5 kg. Okay, so this is how we are calculating the t statistics. So here you can see the table value. Now this is the interpretation of acceptance and rejection region. So you have fixed the rejection region at 2.62, and it was two tail test, so both the sides minus 2.62 or plus 2.62. Now your calculated value is beyond 2.62, so it is falling in this area. So that is why you will reject the null hypothesis. You will reject the null hypothesis and accept the alternate hypothesis. Now another comparison, that is comparison of two independent sample means. So first we compare the population mean and sample mean. Now comparison of two independent sample means. So two independent sample means when the variance of samples are equal. So what we will do, there are two conditions for comparing two samples. The first, when both the samples are having equal variance. So in such case, you have to you require the pooled variance. Why you require pooled variance? Because variance is very important to get the value of standard error. You know the formula of standard error, it is standard deviation by under root n, and standard deviation is the square root of variance. So first of all, you have to get the pooled variance, and pooled variance I have represented it here with s square p. P indicates, s square indicates variance and p indicates the pooled. We combine information from both the independent sample to get the reliable estimate of common variance. So we will get the common variance. In fact, this pooled variance is weighted average. So you have to remember, we have already seen what is the weighted mean. Weighted mean we have studied when we were studying about measures of central tendency. So pooled variance, it is the weighted mean of two sample variances, that is s square 1 and s square 2. So weighted mean of these two variants are called as pooled variance. And weight, what weight we are giving? It is, we are giving the weight of corresponding degree of freedom. And with okay, this is the wrong one, we'll forget this. Now coming to the next slide, here you can see how we are calculating the pooled variance. So pooled variance, I have already told you, it is the weighted average of the variance of each of the sample. So weighted variance, weighted by what? Weighted by degree of freedom. So n minus 1 into s1 square, variance of first sample, plus n2 minus 1 and s2 square, that is variance of second sample, divided by n1 plus n2 minus 2. So this is the weighted average. Pooled variance is the weighted average of variance of two samples. Now if you put the value of this variance, so here if you put the value of variance, the variance formula of variance is summation x square minus summation s the whole square divided by n1 and whole divided by n minus 1. So this n minus 1 and n minus 1 will get cancelled, and in this way you will get, in terms of variance, the formula will be, it will come like this. And if this term, if you are considering it as a sum of a square, so sum of a square 1 plus sum of a square 2 divided by n1 plus n2 minus 2, this will be the formula for pooled variance. Now after getting pooled variance, you have to calculate the standard error of difference. So how you are calculating the standard error of difference? Standard deviation divided by under root n, and that is degree of freedom. So here you are getting the standard error of difference of pooled sample under root variance of pooled variance divided by n1 plus pooled variance divided by n2, and in this way we will get the formula of standard of error of difference as a pooled standard deviation under root n1 plus n2 divided by n1 into n2. So by this way we are calculating the standard error of difference. Now what we have to do? Now we have to apply the test statistics, actual test statistics. So what is the formula for t-test? It is the difference between the two samples, that is mean difference of the two sample divided by standard error of the difference. So what is mean value? x1 bar minus x2 bar divided by standard error of difference. So this is the t this is the t value. Here you can put the put your calculated value. So in terms of pooled variance, this will be the formula. And now after putting this, if suppose you are having both the sample size is equal, n1 and n2 is equal to n, so this formula of t will be changed to this one. And after calculation of t value, again the same procedure as of earlier, you have to see the value of t in t distribution table at degree of freedom will be n1 plus n2 minus 2. Here degree of freedom will be n1 plus n2 minus 2, that is the pooled degree of freedom. and at that degree of freedom you have to see the table. So you can see, just see one example. I will be rushing through this example. This is the example where it is regarding to gain in weight of 2 lots of rat maintained in high and low protein diet. So this is high protein diet, low protein diet, and this is the performance of 2 rat unit. So they both are having different variance. So let us denote weight under HP and LP as x1 and x2. So now you have n1 is equal to 12, n2 is equal to 7. So this is 12 and this is 7. And summation x1 you have calculated, summation x2 you calculated, x1 square, summation x2 square, and now you calculated the mean x1 bar and x2 bar. So the difference of mean divided by pooled variance. So now you will be concentrating on calculation of pooled variance. So how you are calculating the pooled variance? So sum of a square, we already know the formula of sum of a square, that is variance. So with this formula, here you can see this was the formula for pooled variance. So in that we require sum of a square due to first sample. So sum of a square due to first sample, we calculated summation x1 square we know, and summation x1 whole square we also know. So with this you will get the value of this SS1. Similarly you will get the value of SS2. Now you will put the value of this SS1 plus SS2 divided by N1 plus N2 minus 2. So with this you will get the value of pooled variance as 446.12. Now with this pooled variance, this is the pooled variance. Now with this pooled variance you have to calculate a standard error of difference. So standard error of difference is under root pooled variance under bracket 1 by n1 plus 1 by n2. So in this way you got the standard error of difference as 10.04. Now you put this value that is pooled variance and standard error of difference, and mean difference already we have calculated in the last slide. So what we will do, 120 minus 101 divided by standard error of difference 10.04. So the value is coming, t value is coming as 1.89. Now this 1.89 we will compare it with the table at n1 plus n2 minus 2 degree of freedom. N1 plus N2 minus 2 degree of freedom. So the calculated value 1.89 is less than 2.11. If you see the table, you go to the table, you just try to get the value of t at N1 plus N2 minus 2 degree of freedom. So what was N1? It was 10, N2 was 7, 10 plus 7, 17 minus 2, that is 10 plus 9. 12 plus 7, 19 minus 2, that is 17 degree of freedom. You just check and see what is the calculated value of t at n1 plus n2 minus 2 degree of freedom. So it is coming 2.11, and which is lesser than 1.89, the calculated value. So what we will do here, we will accept the null hypothesis and reject the alternate hypothesis. So therefore we conclude that gain in weight of rat under 2 diet is not real. So that means the 2 feeds that we are feeding are one and same. The difference is just because of chance. There is no difference. There is no such difference exist between the feeds, and due to that feed the rats are not gaining that much, or there is no significant difference between the gain by these 2 feeds and the rat. So here you can see the rejection region is 2.11. However, our calculated value was 1.89. So what we will do? Our value lies somewhere between these. So we will accept null hypothesis. That means there is no difference between the 2 feeds. Now another situation, when the variance of samples are unequal. So this situation we are rarely asked in examination, but just for knowledge we will see I will not discuss any practical example on this aspect. But just for your information, I have discussed this. When the variance of samples are unequal, the student t-test performs badly. When it performs badly, when you have unequal variance between the two samples, and also there is chance of committing type 1 and type 2 errors. So unequal variance t-test forbid the assumption of equal variance. When we were performing t-test, then at that time we were assuming that variances should be equal between the samples. So this situation will forbid that assumption. So moreover, the degree of freedom will also, it will not be n1 plus n2 minus 2, it will be changed. So how this t formula or t statistics will change? T dash. So in this situation we are calling it as a t dash. T dash is equal to the mean difference x1 bar minus x2 bar divided by the variance s1 square divided by n1 plus s2 square divided by n2 all whole under root. So this is how the formula of t statistics will be there when variances of the samples are unequal. Now degree of freedom will also be changed. So just here I have written the formula. If you are interested, you can go through this. You can refer any standard textbook. Standard textbooks means you can refer book by statistical method by Dr. S.P. Gupta, by S. Chand publishers, or any, for that reference, any standard textbook you can refer. Now here the effective degree of freedom, if you see the formula, you will not get, many times you will get degree of freedom in fractions, suppose 20.8 or 20.2. So in that case you will change it to the nearest whole number, that means 21, or here 20. So this is how we are deciding the degree of freedom when the variance of samples are unequal or they are not equal. Now the last but very important is the pair t-test. Pair t-test, or it is also known as two dependent sample t-test. So when you are having paired sample, so for comparison of those paired sample, you need to do pair t-test analysis. So here we are comparing two means where two sample in which observation in one sample can be paired with observation in other sample. So when you are having paired sample, these paired sample are also called as matched sample or repeated measures. Matched sample or repeated measures. When the observation is paired, that is correspond to same unit, then the test of significance is called as pair t-test. So in case of paired sample, you are doing pair t-test. So paired, by I think with these lines you might have an idea about the paired sample. What is paired sample? Suppose you are doing one experiment, you are trying to find the value of the effect of a feed. So what you are doing, you are taking some body weight measurement on the group of animals. So first you taken the body weight measures of 5 animals and you did experiment. Now next, after taking weight, you fed those animals with that particular feed sample, and then after feeding also you taken the body weight. So these body weight you are taking 2 times, one before feeding and another one after feeding. So these two observations that you are getting before feeding and after feeding, these are the paired sample. Likewise, you can see lot many examples in the day-to-day life of pair t-test. So the two sample pair t-test for mean determine whether the difference between the before and after measurement is real or not. So now you want to see whether before weight that was taken before feeding and weight that was taken after feeding, is the difference is real or not. So for that you have to go for pair t-test. So how this pair t-test works? The pair t-test is useful when there is natural pairing of the sample. So what we will calculate the difference between the paired value. So you are having paired value, suppose animal number 1, before feeding the weight was 5 kg and after feeding it was 5.1 kg. So we will take this difference 5.1 minus 5, that means 0.1. So difference will come 0.1. So we will calculate the difference D between paired value. Now analyze D as a separate variate. So we will create another separate column for D, that means difference, and then we will analyze that column. Then calculate the mean and standard error of D. So we will calculate the mean value and standard error of that particular D, and then with that you will calculate the significance difference between from 0. You will calculate the difference between 0, whether this difference is 0 or it is something else. Okay, then we will see one practical example, then it will be very much clear to you. Now, what we are doing, suppose, now you have to perform the test. How you will perform the test? You will first put null hypothesis, that means D bar, mean, that is mean of the difference. Mean of the difference is 0. That is null hypothesis, which implies that mean difference is 0. Another alternate hypothesis is mean difference is not 0. So these are the null or alternate hypothesis. Now you have to calculate the t statistics. So you know the same formula but in different format. T is equal to difference of mean. We were using it as a if you are comparing two samples, then difference between two sample mean. If you are comparing population and sample, then it was difference between sample mean and population mean. But here it is the mean difference D bar, mean difference D bar divided by standard error of that particular difference. Standard error of that particular difference. That means D bar divided by standard deviation divided by under root n. Okay. So difference of mean difference or what? Summation of all the difference divided by number of observation. And with this you will find the standard deviation, and with standard deviation you can calculate the standard error value. So now this calculated value, if with this if you got the standard error of difference and difference already you know, so you will put the value in this formula. In this formula you will put the value and you will get the value of t, and this t value you will be comparing with it with the table value. So now just see one example, then it will be crystal clear to you. So suppose this is the data from the following information on milk yield of crossbred cow. Test whether the milk yield is same in morning and evening. So what we have to test, this is the record of morning milk yield and evening milk yield. Now you want to know whether there is any difference between morning milk yield and evening milk yield. So what you will do, just you see these are the 10 observation. These are the 10 observation and morning and evening milk yield. So you will find the difference. So 6 minus 8 is equal to minus 2. Then similarly you will get all the differences written over here. Now you sum up all the differences, and forget the sign. You sum all the differences. So sum is, that means summation D is coming as 15. Now similarly you calculate the D square, because you have to calculate the standard error also. So D square, or that means summation D square will be 43. Now this is the null hypothesis, that means D bar, mean of the differences, will be equal to 0, and alternate hypothesis it will not be equal to 0. Now you just put the value D bar is equal to summation D by n. Summation D was minus 15 divided by 10, that is minus 1.5, and now you have to calculate the variance. So variance is equal to 43 minus 15 square. So anyhow, if you are squaring, the sign will go. So in this way you will calculate the variance is equal to 2.27, and standard deviation is 1.506. With this standard deviation you will calculate the standard error of difference. it is 0.476. Now with standard error of difference, you will calculate the t statistics. T is equal to mean difference divided by standard error of the mean difference. So mean difference was 1.5 divided by 0.476, it will be 3.15. So calculated value is 3.15. Now you have to see the tabulated value. At what degree of freedom? So the degree of freedom here will be n minus 1. So what was n? The number of sample was 10. So n minus 1 will be 9. So at 9 degree of freedom, the tabulated value is coming around 2.26. So 3.15 is the calculated value and tabulated value is 2.26. So the calculated value is greater than tabulated value. So we will reject the null hypothesis and accept the alternate hypothesis. That means there is significant difference between the morning and evening milk yield. So this is how you will perform pair t-test, and this is how you will interpret the results or interpret the value that you have got from the t statistics after consulting the t distribution table. So in this way, I am completing the t-test of hypothesis, that is hypothesis for testing small sample size. And then in the next class, we will see probably the F distribution or F test. Thank you.